The ocean is a vast, mysterious world, covering over 70% of our planet. Beneath its surface lies a hidden force that's shaping the Earth in ways we're only beginning to understand: geothermal hotspots. These are places where the Earth's internal heat seeps into the ocean, creating unique environments that influence marine life, climate, and even the planet's geological future. Today, we're diving into the science of these underwater powerhouses, exploring how rising ocean temperatures and geothermal activity are intertwined, and what it all means for our world. Let's start with the basics. Geothermal hotspots in the ocean are areas where heat from the Earth's core escapes through the seafloor. This heat comes from the planet's molten interior, a churning cauldron of magma and radioactive decay that's been active since Earth formed over 4 billion years ago. In the ocean, these hotspots often manifest as hydrothermal vents, underwater geysers that spew out superheated water loaded with minerals. These vents are found along mid-ocean ridges where tectonic plates pull apart, allowing magma to rise and heat the surrounding water. Hydrothermal vents are like the ocean's volcanoes, but they're not just hot water fountains, they create entire ecosystems. The water they release can reach temperatures of 700 degrees Fahrenheit, yet life thrives there. Bacteria that feed on chemicals like methane and hydrogen sulfide form the base of a food chain that supports creatures like giant tube worms, blind shrimp, and bizarre fish. These ecosystems show us how resilient life can be, adapting to extreme conditions where sunlight never reaches. But geothermal hotspots do more than sustain strange marine life. They play a role in regulating the ocean's temperature. The heat they release is a small but significant part of the ocean's energy budget. On average, the ocean floor releases about 1/10 of a watt per square meter of heat. That might sound tiny, but over the vast expanse of the seafloor it adds up to a massive amount of energy. This heat influences ocean currents, which act like a global conveyor belt, distributing warmth and nutrients around the planet. Now, let's talk about rising temperatures. The ocean is warming due to climate change, absorbing over 90% of the excess heat trapped by greenhouse gases. Surface waters are getting hotter, but what's happening deep down near these geothermal hotspots? Scientists have found that these hotspots are becoming more active in some regions, possibly due to shifts in tectonic activity or changes in ocean circulation. Warmer oceans can alter the pressure and chemistry of the seafloor, potentially triggering more intense geothermal activity. It's a feedback loop we're still trying to understand. One fascinating example is the East Pacific Rise, a mid-ocean ridge where tectonic plates are spreading apart. Here, hydrothermal vents are pumping out more heat and minerals than ever before, possibly because warmer waters are changing how fluids flow through the Earth's crust. This increased activity could release more greenhouse gases like methane, which is trapped in the seafloor. Methane is a potent greenhouse gas, 25 times more effective at trapping heat than carbon dioxide. If these hotspots release more methane, it could accelerate global warming, creating a vicious cycle. But it's not all doom and gloom. Geothermal hotspots also offer opportunities. The minerals they spew out, like copper, zinc, and even gold, are sparking interest in deep-sea mining. These resources could power the green technologies of the future, like electric vehicle batteries. However, mining these areas is controversial. It could destroy fragile ecosystems that took thousands of years to form. Scientists are racing to study these habitats before they're disturbed, trying to balance economic potential with environmental preservation. Another exciting aspect is the potential for geothermal energy. On land, we've tapped geothermal heat for power in places like Iceland. In the ocean, it's trickier, but researchers are exploring how to harness this energy. Imagine underwater power plants that use the heat from hydrothermal vents to generate electricity. It's a long way off, but the idea shows how these hotspots could contribute to a sustainable future. Let's zoom out for a moment. The ocean's geothermal hotspots are part of a larger system. They're connected to the Earth's climate, tectonic activity, and even the carbon cycle. For instance, the minerals released by vents can absorb carbon dioxide, acting as a natural sink for this greenhouse gas. But as oceans warm and acidify, this process might slow down, reducing the ocean's ability to mitigate climate change. It's a complex puzzle, and every piece matters. Scientists are using cutting-edge tools to study these hotspots. Robotic submarines, or ROVs, dive thousands of meters to map the seafloor and collect samples. Satellites track ocean temperature and currents, helping us see how geothermal heat influences global patterns. Computer models simulate how these hotspots might change as the planet warms. These tools are revealing just how dynamic the ocean is, constantly shaped by forces deep within the Earth. So what does the future hold? If ocean temperatures keep rising, we might see more intense geothermal activity, which could reshape marine ecosystems and influence global climate. We need to keep studying these hotspots to predict their impact. They're not just geological curiosities, they're key players in the Earth's climate system. Protecting these areas while harnessing their potential could be a game changer for science and sustainability. The ocean's hidden geothermal hotspots remind us how interconnected our planet is. From the depths of the seafloor to the atmosphere above, every system is linked. Rising temperatures are a challenge, but they're also a call to action. By understanding these underwater powerhouses, we can better protect our oceans and our planet. So the next time you think about climate change, remember the heat rising from the deep. It's a small but mighty force, and it's shaping our world in ways we're only beginning to uncover.